Hello and welcome to another episode of the Proof of Claim podcast. I'm your host, Todd Price. I'm joined with my co-host, Anil Bharrat. And today we've got Jeff Harris on. So we were just trying to get an explanation of what Jeff is to introduce him in his edification. But he's a veteran of computers. He's been in the game for over 30 years in all kinds of distributed applications, distributed systems, network engineering. So he's kind of touched every point of the stack at some point throughout his career. I met Jeff at the London Blockchain Conference in 2023. We shared a couple of days together manning the BSVA booth. And we had a great set of conversations, just going deep into the technology. And it was a real privilege to get to speak to someone who'd had the intimate experience building out Terranode, understanding how the system worked, understanding how it interfaced with the broader network of the internet, and being able to address any questions at any level. So I'm hoping today we can really get deep into some of the technicalities of Terranode and the future directions that we're going to have to take the Bitcoin in to scale it to a planetary level. So welcome, Jeff. It's great to have you here.
Thank you. Thank you for having me. Appreciate it.
I've been following you on X and LinkedIn, and just seeing that you've been pumping out a bunch of code related to what your claims are. This is how we get Bitcoin scaling past the single digit millions into several orders of magnitude above. So I'm keen to get you on here to prove your claim, or just at least substantiate it, and let's see how we take this to learn about what the future looks like for these kind of blockchain systems, and what you're aware of in terms of the feasibility for scaling Bitcoin, as well as the feasibility of scaling other blockchain systems, and how does that looking for you? So welcome, and let's get into it. So do you want to share a little bit with what you've been recently working on with your Bitcoin multicast sharding proxy, or whatever the label was on that?
Indeed, it's actually evolved into kind of a network suite. There's a bunch of moving parts. The main thing is that we need to be able to distribute transactions efficiently across the planet in a fair manner, and it needs to do so in a scalable way. And it requires, in order to meet that scale, it requires a substantial investment. And that means standing up a real network to make it happen. The way that Bitcoin has scaled thus far is through various peer-to-peer public internet type structures. The current structure is a libp2p gossip-based distribution mechanism. Basically, lightweight announcements from nodes get sent out, and then many other hosts all download from that node. And it ends up being a little bit tricky because of the amplification of bandwidth that starts to occur at certain throughputs. It's kind of my supposition that about 3 million, maybe 4 million transactions per second is actually going to start running into problems, because most hosting providers have 5 gigabit, 10 gigabit flow caps for a single server. 10 gigabit internet is pretty standard these days. 25 gigabit is even more, but bandwidth is still a darned premium. And hosting providers tend to treat it like almost as a capture mechanism, right? For instance, AWS makes it they make it free to get data onto their network, and then they make it expensive to get it out. Other hosting providers have their own types of games that they play. They'll give you up to maybe 3 gigabits, but then to push up to 5 gigabits, you're spending $800 more a month, right? there's just all kinds of funnels that push you into higher spend usually. And that's just the hosting game. It's just the way the game has evolved. And so Bitcoin, in order to break out of the science project status and to get to real commercial stability, it needs to be professionalized. And on a public internet level, that is data centers, co-location, internet exchange points, transit, not transit, but peer-to-peer direct connections in data centers, larger links than 10 gigabit, 100 gigabit, 400 gigabit. We've got 1.6 gigabit or 1.6 terabit network interfaces now that they're testing. And the fiber is still there and still viable. You just change the interfaces and you're good to go. The network scales the most. I don't know if you've ever seen charts of Moore's law put next, overlaid on top of where memory scales, storage, etc. Bandwidth actually scales the most. Network always has, just because the innovation with light is more pronounced. So
it's less bound by the material manipulation. You're essentially just optimizing how the photons are arranged in a tube or a fiber or something like that.
Yeah,
being able to write to the frame.
Yeah, and the small world network requires very dense connections between the hosts, right? The miners, and the faster that happens, the more money they can make. Less latency, more transactions, more connections. The network becomes a utility, and Terranode is kind of an engine, right? A race car, but it needs a track, and the network's the track.
Yeah. It seems there's a few operators running it now, but trying to put 1 million transactions at them, I don't have the highway to put that much traffic to it. Like my laptop, I've maxed it out, sending 15,000 transactions a second to Arcade, but then the router from my home's not going to be able to let me do that. Send more than that, really, or maybe it would.
But actually, 10 gigabit consumer based fiber is actually a thing in certain places. I don't have it, but other people do. And I think you can get 1 million per second across 2 gigabit. That's no problem.
Right.
There's also, you have to think about the transaction flow, because it's supposed to come from users, right? It doesn't come from miners. Miners just accept transactions in, and then they verify them and they share them with others, right?
Yeah.
So the source material comes from a person that everybody knows and loves, and he wrote very deeply on the subject of how to actually scale the core of the miners. And so my implementation is based on that design. And in this design, it breaks apart the Ingress users from the core consumers, which are the miners. On top of that, it's services, overlays. And on top of that, it's users, right? If you think about what multicast is, just think about it from the standpoint of one transaction. One transaction, we're putting it on the wire. It goes to every party across the planet at once within milliseconds. That's the goal, right? To create a multicast fabric that actually traverses the entire globe to consumers that actually need it. So
what is, I know, but I think many people don't know necessarily what multicast is.
That's exactly what I just described. It's the ability to put a network packet onto the wire, and then subscribers anywhere else on the network receive that transmission all at once.
And that's different than a unicast arrangement.
Because a unicast is one-to-one, right? And a multicast is one-to-many.
So if you're having, before you mentioned lib P2P as a gossip, so if you're putting a packet on the wire under gossip, you're gonna then, and you've got 10 peers, it's going out, and if the packet is, you know, whatever, 220 bytes for a transaction, it's going out as to, you know, be 2,200 bytes, but on the
and it actually doesn't even work that way now. Since we have Terranode, the old peer-to-peer worked kind of like that. Excuse me. The new peer-to-peer, Teranode actually announces subtrees.
Mm-hmm.
And when they announced the subtree availability to the gossip network. The gossip network's made up of miners, those running Teranode and other peers, right? Those peers reach out to that Teranode's asset server because there's a data URL inside that announcement. So they go out and they talk directly to the Teranode and pull that data, right? If they pull the subtree data, if they're missing any of the transactions, then they pull the transactions from them too. So already it becomes an exponential bandwidth problem the more participants there are. And honestly, it's never been tested over the public internet. We did test it at 1 million plus per second across the internet, but it was riding on AWS's network. And so, and it actually used VPC peering so that we rode across AWS's actual network links. It never left their network. So we've never tested it on separate public internet connections. I think it'll probably be fine for 1 million, 2 million. But like I said, depending upon the hosting provider, at some point those flows are gonna start running into bandwidth caps, and it might get pretty expensive really fast. And the other thing about this is every miner then has to run their own network operations. They've all got to decide that, okay, well, we've got to allot for so much bandwidth, and, you know, we have all these people pulling all this stuff, and, you know, and it changes, you know. There might be periods of lots of usage. There might be periods of not a lot. It becomes another operations expense, right? For these miners that their business is validating transactions, creating blocks. That's their business.
Disseminating the ones they've received to others.
Yeah. So what I want to do is to create many ingress points all across the globe. You send your transaction to a standard DNS address, standard IP address. Anywhere you are on the planet, it goes to the nearest ingress point, hits the multicast fabric. The multicast fabric transmits it everywhere across the globe, directly to Terranode. I want to front run the lib P2P pull process. I don't want to replace it. I want that there in case there's it needs fallback, right? In case in case they didn't receive a multicast transmission for whatever reason, which is very unlikely the way that the network is actually designed, by the way. We get into that.
Your network that's designed, or the multicast?
The multicast. Fabric? Yeah, the way that the multicast frame format works, and the ability to retransmit and actually fill gaps. If it's like magic. We'll get there. Anyway, for now, what I'm saying is that libp2p gives it gives assurances up until a certain throughput level, a certain threshold, right? Beyond that, it's not really tested at super high throughput. So anything can go. And the math that I've seen shows that it starts to break down for various reasons. So this is just the next step. It's just the professional network. That's all that this is. But we have to do it in a way that's smart.
And so you got the, some of the brief from the article that Craig published.
Yes.
Like, how much of that was, revolutionary to you or novel to you, or like was it, or did you already know most of that and it just helped you formalize it? Or
absolutely not. So the article that we're talking about was written in September of last year, 2025. It was called Multicast and Multicast, and Anycast, I think, was in there also. I don't know. It was a long title. Anyway, I started reading that article in January of this year. I took a little bit of break after the Terranode project and rested and relaxed, and then started getting bored. So I started reading in January. It actually took me a while to understand it. I had to read slowly and digest, but as I started experimenting with some of the ideas in it, I started to realize that, this might actually be more doable than I first realized. Because you got to understand, in 2023, when we first started looking at multicast, when Jake Jones and I were looking at it at BSVA, no one had any clue. Like, I knew how to put together a unicast routing network and then stand up PIM on top of it. I had never done it before, but I figured it out, and we got actual multicast working, but it wouldn't work across AWS just for various reasons. So, so we kind of abandoned that because we really wanted to hit our 1 million TPS goals, and we did a couple months later. So I didn't really even think about multicast the rest of the time that I was working on Terranode. So this year, January, I picked this up. The biggest thing to understand for me was how to do the actual sharding of the transaction flows. So the idea is that we've got 1 billion transactions per second, right? You can't process 1 billion per second on one computer. Doesn't work. And you can't flow that many over one network connection, really, because it's terabits of data, right? Maybe someday, but not today. So what you have to do is you have to break this up in a deterministic way so that it can ride multiple lanes at once, right? So think about it as a highway that can take so many cars, and in order to alleviate this, well, you just stand up a new one right next to it. And the cars that are going down these lanes, they all conform to a certain address, right? A certain portion of the SHA-256 or the TXID address space, right? Or the actual SHA-256. So you take the big Indian version of that, and you do a little bit of fancy bit shift math. That's all you got to do. And you split it deterministically into groups. And so you decide, okay, well, shard bits 0 is all in one group. Shard bits 1 is 2 groups. Shard bits 2, 4 groups. The magic is that those group names never change. So if you've got 10, let's just say you have 10 subscribers on the network that all want to see, they all are expecting to see traffic on this one group, and then you shard it into 2. Well, all they have to do is join the new group, and then suddenly they've got the entire flow. And you can keep doing this. I've designed it to where you can split it into 4,096 different lanes like that. But can you imagine managing 4,000 network links like that all had different group subscriptions on them because they all had a different piece. So I think that's way too many, but it is what it is. It's there. Because I think as time goes on, network interfaces get faster, right? The more bandwidth, right? So there's always a push-pull between those two things. So you can shard more, or you just upgrade the links. Either way. So the core of the network, the part that's passing 1 billion per second, can be split up into different groups. So you could split that up into 12 different groups of 100 million each, right? You've got 1.2 billion total.
And you're essentially indexing instead of getting the state explosion of multicast, you're just indexing via the leading bits of the TXID.
Yeah, that's for the transactions. Yes. So basically, when they hit the proxy makes a decision. It says it looks at the TXID really fast, and it says, okay, which group does it belong in? Put it here. Pass it on through. It also does some stamping, which is it's stamped with a composite hash key that's made up of the source ID, the source IP address, the group index that it's on, and also the subtree ID that's added to the transaction as well. So there's 3 dimensions there. And then next to that, there's a monotonic sequence number that's, I think it goes up to 4 billion. So as the proxy is sending these packets out, it's stamping them with a key that can be used to re-look up that frame. People that are watching probably don't know, but multicast is not it can't guarantee delivery. First off, it uses the UDP packet type, which doesn't have any provisions for retransmission like TCP does. TCP is a reliable protocol and UDP is not. So when you put a packet on a multicast network, there's no way to guarantee that everybody has got it, except for your network convergence skills and reliability thereof. And so you need a way for receivers to identify if they've missed certain transactions. So think about a transaction comes in Japan, and somebody in California is trying to listen for this entire transaction stream, and one gets missed. Well, what can you do? Well, you look at the sequence. You look at the sequence of the flow, and you realize that you've got packet number 10 and packet number 12, but number 11's missing. So you take the composite hash key and that sequence number, and you request a retransmission. And because it's on the multicast network, you can have many retransmission points. And all they have to do is cache the entire flow of transaction data over a period, a time window of like maybe a minute, maybe 10 minutes. I don't know. It depends on how granular you want to get. And at 1 billion per second, it starts to, there's a lot of keys there, but it's just RAM. It's just RAM and servers. And so all you've got to do is load balance the incoming retransmission requests. If you have a reliable network, you never need a retransmission request. So what happens is you've got transaction comes in ingress, gets put on the multicast network. It goes end to end to n number of consumers, miners. At that edge, before it gets delivered to the miner over unicast, TCP, so that it's reliable, it just repairs any gaps. So if you have a network cut, if you have an outage of a router, the thing can actually heal itself, because all you have to do is a second path, do a retransmit request. You've just filled all the gaps. So this isn't novel, because the Navy actually has a protocol. It's called NORM, NAC-oriented reliable multicast protocol, and theirs works a little differently because it's kind of block oriented, and it does some optimizations for like retrieving missed pieces for other consumers also, but we don't need any of that because we have transactions are just an atomic unit, right? It's just send the transaction through, just put it out on the end. We don't even need encryption. We don't need anything because Bitcoin's public, right? It's literally just delivering them. It's like a reverse post office, you send your transaction for free everywhere, and then you miners pay to receive it. That's the idea.
So that's your sort of route to commercialization, is by you giving them that reliability and an efficient way of ingressing that they would subscribe to the service.
And there's really no other way to do it that I can think of, because as this thing scales, you need those direct connect data center port connections, because like I said, over the internet, flows start to break down. So it turns into private connections between miners, but this allows all the miners to streamline their network ingress to one flat rate, which is the entire rate of the network, the overall TPS of the network. So rather than potentially having bandwidth spikes because of that issue we were talking about with libp2p and other miners suddenly hitting them for information, you just deliver it steady state to all continuously. That's the idea.
And so what you're trying to do is create a system that scales unboundedly here, that you can just sort of commoditize a reliable delivery of that to everyone, and you just have this sort of fabric that they can count on, and they need to come to you because you're the one that's
well. So I've also designed it for competition, so it works interdomain. It isn't a proprietary solution. So all the code is open source, all the standards are open source. They're designed for source-specific multicast, which actually works across interdomain links. The problem is that no ISP on Earth, well, not on Earth, but no major tier 1 ISP, tier 2 ISP accepts multi-protocol multicast across their transit links, right? It stops at the ASN boundary because it's been considered kind of a security issue, honestly, because of DDoS and all kinds of other fun things. So my solution's designed to be interdomain. So if somebody else wanted to stand up their own network, we could peer together. We could have ingress points and miners on both sides. It worked just fine. The solution works just fine. But somebody's got to stand this thing up. And as far as I'm aware, there's not anyone else in the BSV space that's focused on the data center and the network and anything above scaling Terranode itself. Right.
I'm not aware of it. Maybe there's a couple of. There might have been a spurious claim from someone about beginning to.
Actually, Ty at Babbage did some work thinking about multicast, and I've read his work several times actually, and I like some of his ideas on resource configuration, resource selection, I guess is a better term for it. But it didn't really go far into actually spelling out how to build a network, right? How to architect it for scale. And the source material I used did. So
what does that say to you that you've got a 30-year career in this sort of stuff, and obviously you know what you're talking on, and then you read an article by someone else that gave you a whole lot more.
It's divine inspiration. That's what I'd say, because it came at the perfect time. I needed a new project to pivot to, and this one sounds really cool. So
from your capacity to sort of discern that, does the individual that published the article have extreme knowledge of these kind of systems and networks and such?
Well, I tell you what, the implementation details weren't there. It was just a design. It's just a design. I had to figure out how to build it. So it's been sweat equity in this,
Yeah.
But it comes because I've built networks, routers, switches. I did a lot of Cisco certifications decades ago. I was running an ISP in 1995, so I wasn't running it. I was a junior sysadmin. I'm not going to get ahead of myself there, but I was a 17-year-old junior sysadmin, right? So I'm not a computer science background, not academic. I've always been a working engineer, and I've just kind of worked my way up. I've worked at startups, I've worked at enterprise, retail, government, like all kinds of ISP, service providers, all kinds of stuff. So I've had a lot of cool experiences.
And we kind of jumped, straight into the weeds then, but
we did.
Just on the little pre-call, Anil asked you, how did you get into Bitcoin? When you got into it, and so that's what you shared was a very early entry into it. And how much has what has it been, 15 years or something, 16 years since then? How much has Bitcoin occupied your passion at the same time as your experience in network engineering and system engineering?
Yeah, actually, good question. So just to relate the story, found Bitcoin late 2010. By early 2011, I was mining it on GPUs because that you could still do it for $100. Get a nice Radeon card. I was along for the ride all the way up through I remember the first My Bitcoin scam or whatever. I'm thankful that I didn't actually lose anything in scams and exchanges going bust and whatnot. I had a good friend who lost a bunch on empty Gox, actually. And it sucks because I knew something was going to happen, and I didn't tell him because I don't know why. I kind of kicked myself that I didn't intervene, but I lost touch with him, so I don't know what I don't know if he ever got made whole or whatever. I think people waited forever about that. Anyway,
I think that people that get made whole more like maybe 2-3 years ago or something like that.
Yeah. He it was unfortunate. Anyway, so around 2013, I actually started working for a large managed hosting provider, one of the big, at the time, it was the fourth largest cloud, company called Rackspace Hosting. And I founded the Bitcoin and, I called it cryptocurrency group because back then I didn't understand the difference between Bitcoin and cryptocurrency.
Well, how would you define the difference then? Just for
cryptocurrency means secret money, and Bitcoin is not secret. Bitcoin's public. And also it's cash, not money. Right? Money's a different legal definition. It has different connotations, right? So what we're working with here is electronic peer-to-peer cash. And and so I should have called it the Bitcoin group, but by 2013 the lines were murky, let's just say. So I was always a Bitcoin advocate. I encouraged other people to contribute as much as possible. The thing is I never really waded deep into the waters with Bitcoin, professionally, commercially, hobby. I helped a guy recover some lost wallet passphrase or whatever. Did some odd things like that. But I never really worked with it like that until I ran across the Unbounded Enterprise guys way back, what was that, like 2016, 2017, whenever that was. Kind of worked with them for a year or two. Really, that didn't really work out, unfortunately, for them. I think they got caught up in some I think they got caught up in the Kristen Egger Hansen affair, unfortunately, because they were one of the businesses that InChain went, well, while he was CEO, did some deals or something. I'm not privy to any of that stuff. I don't know how it went down, but
pretty one-sided.
Yeah, I can only imagine that actually contributed to asset layer failing afterwards. So I'm not sure.
Yeah.
It sucks for Jackson Lasky, because he's a really great guy. And Dave Mullenmeyer also. I really like those guys. Anyway, did some of that work, and then some other things. And then fast forward to 2023, I'm working for BSVA, working on Terranode, actually doing my actual dream job. I got recruited in from a friend of mine who I worked with at Rackspace, actually, because he went to AWS and wound up being our
man on the inside.
Yeah, man on the inside. Not actually officially. He dedicated his time to Terranode because he believed in it. Yeah, he didn't get paid. I don't think he really got credit for it, as his job at AWS. Like he really stuck himself out believing in the project. So I got to give him, he knows who he is. So got to give him some props.
I spoke to him last night, and he said that you guys are in regularly chat, and
yeah,
it sounds like he's getting a little bit of traction now with customers who are interested in using the tech, and he's got some things and some prototypes, and he's saying, what is the the coherent suite of tools that can offer, and I was sharing some of the stuff I've been working on with him, and in particular, he had an IoT customer, and I said, "Oh, check out this little edge kit I hacked together. See if there's anything of value in there." And I'm keen to cross pollinate and hope that something crystallizes that just delivers a killer solution to some particular use case. And if you get a couple of those wins, then a whole like IoT in particular, I think that industry, if I was down at the IEEE conference a couple of weeks ago and sitting next to associate professor from Japan, and he was saying they were trying to do sharded lightning network IoT stuff, and they're just publishing their negative findings. And I said, you can do 100k TPS for fractions of a cent, and he was like, really? I'm like, yeah, L1. I'm very interested by that. Like I've got smart factory, smart city, aspirations that we want to do as a research project. And so that was my kind of inspiration to sort of formalize some of the little tinkering I've been doing on the ESP32s and that, and wrote up a little edge kit for him and said, have a look at this, see if it makes sense. You probably know the issues and what the requirements and such, but maybe this is a bit of a head start to look at it. So shared that with the mutual acquaintance, and hoping someone can deliver something.
Yeah, I'm glad he's still at it. I'm glad we all are, honestly.
Yeah.
We're like the it's whittling down to a core group of hardcore enthusiasts.
Yeah. I got the bug. I can't really imagine, it's the hard path, but I can't really imagine pivoting to go anywhere else, because it's just like, this is, when you have the conversations having with you, there's very few people I can find, but when you do it, you're like, where else would I rather be than at the tip of the spear of scaling,
Yeah.
money, peer-to-peer cash and data, a data plane for, you can just see the relevance to every vertical, and you see the inefficiency, you see the value lost in fraud, and a lack of data integrity, and a lack of being able to trustlessly coordinate between, not necessarily like adversarial, but non-guaranteed to be, always cooperative, lossless channels and such. And that's the solution for it. But it's most people don't even, if you talk about data integrity, they don't, it makes their eyes glaze over.
What is that?
Yeah. Or you talk about a digital identity, and they're like, oh yeah, I just log into my account, and
I have to be honest, like I'm not the one that's I'm not deep into script engineering, decentralized identity solutions, wallets, none of that. I try and keep abreast of all the BRCs that I can, but I've got my own that I'm working on, and I'm kind of working on a different layer of the stack than I think even all the other Terranode engineers were, which is the actual infrastructure, where the systems are, the operating system, the network, the storage, all of these, the clusters, all of these lower level solutions that are required in order to run the thing, right? But also scale it. So I find that it's a very lonely existence, because honestly, I've been working on this project for I'm in my 7th month, if I count, studying for the first month or so, and then starting to write code, 6-7 months in, and I still haven't had really good peer review, or, people telling me, well, you're doing this wrong. I'm kind of operating in a bit of a vacuum. I try and share things with people as I can. But I think a lot of the focus at BSVA in particular has just been on getting Terranode running, getting it up and live, getting SVNode off the network, or at least building everything so that can happen. And so I just think that a lot of people haven't had time to really think about this, but I feel like I know everyone wants to know where the throughput's going to come from. Where are the transactions actually going to come from? What are the solutions, right? I have a feeling that, well, I know for a fact, like in my head, I've got certain sources of transaction entropy that I know could drive throughput through the roof, but getting to that point, commercial solutions is another story. But I think a lot of it is going to come down to plumbing, stuff that's on the back end that no one really thinks about, because Bitcoin can just do it easier, or more accurately, more transparently, not even transparently, more accountably. We'll just say that. And I really think just to close that out, I really think the solutions are actually going to come from science, high performance computing, academia type work first. And I think that's going to get the throughput numbers up there into the millions. And then either we're going to get eyeballs, or we've got to figure out how to scale past that for sure, because you can't stop, right? Scale or die. And you can't stop at 1 million. You got to keep going. So,
but also there is that, like how we were just talking about this with Connor the last week, right? Like there is an actual ticking time bomb that we're facing. We have to actually get enough transactions on the network to.
As long as someone's willing to expend the power output for hashing gear And to maintain it, honestly, this coin could be $1, and I bet somebody would believe in it enough to keep spending that money. I mean, if it came down to miners had to sell Bitcoin to survive, then I'd agree with you. But right now we've got certain people that really believe in this project, and I don't believe that they're going to leave us at the mercy of coin price economics. They haven't already. We're still here. We still have a viable chain, even through all the wars, the hash wars, et cetera. Even with it only averaging, what is it, like 40 something transactions per second now. I know we've had a lot in the past.
Yeah.
But honestly, right now, okay, think about this. We've topped SV node out at 13,000 transactions per second. We've kicked apps offline. We've kicked nodes offline. We've caused all kinds of havoc anytime anyone tries to blast transactions out there, no matter if it's a legitimate app or if it's testing, spam, whatever you want to call it. Oh. It's not spam. If it's a paid transaction, it's legitimate. Anyway, it makes no sense to expend any revenue on that right now. What makes the most sense is to spend the money on scaling the software so that you don't run into those roadblocks, right? Mm-hmm. And that's exactly what's been happening the last 2 years. We're getting really close. I think by the end of the year, I hope we've got SV node off the network so that we can start hitting the Terranodes that are on there with a lot more. And it doesn't take that many Bitcoin to run 1 million transactions per second continuously, right? And a lot of that goes right back to the miners, which might have a incentive to do more. Like there's Bitcoin's got its own economics when you start to add actual throughput on top of it. It changes everything. I would agree with you though. The halving I watched that episode, by the way, just to let you know. I watched it yesterday or the day before, and I do agree with you that the halving is coming up, but I don't think the economics solely depend on the coin subsidy right now. Even in 4 years, when it's, what is it, like one something or whatever,
7, I think.
Or 6 years, whatever it is, when it gets under 1,
Yeah. 0 point something would be 0.7, I think, would be the second halving after.
As long as the miners are being paid in transaction throughput, no problem.
But if they're not, that's what I'm saying though, right? Like I realize we need to get enough transaction volume because the block reward subsidy is going to be so little.
Yes.
So like that's what I'm saying. We have a ticking time bomb.
There's no incentive to actually mine it. Yes.
I
agree. So the incentive actually has to come from somewhere else. So in the absence of throughput, in the absence of coin price, the incentive has to come from somewhere else, and that's going to be the goodness of somebody's heart.
God.
Who wants to keep BSV alive? They have so far. I mean, there's a lot of people that are really invested in this project.
Really, I get that, but we can't really rely on that.
No, we can't rely on that. So the push is get the thing scalable, get the throughput figures there. And like I said, if there's a research project, if there's a university project or something that's funded to do some kind of scientific thing that you've never been able to do before because we've never had a distributed transactional system like this.
Yeah.
Who knows? And, we used to have tons and tons of traffic on BTC. I remember being on the old Bitcoin Cash Slack when all of that transaction traffic just stopped. And I remember because our friend Dr. Wright was on that chat too. And he was it was like nod, wink, wink, I don't know what's going on, meanwhile, the traffic had just been going up like this. And then all of a sudden it just starts. And it was doing nothing. And I'd never seen that before in like 10 years, of Bitcoin, whatever that was, however that long. what 20
years, something like that.
2017, yeah, 2017, 2018. It was right during that time, you know. Anyway, we used to have research transactions. We're going to have those again. I know it. I feel it in my bones. I know that's a very old fashioned way to think, but that's just the way there's no reason to spend all of this time and effort to build something like Terranode if that's not coming. That's just where it at. I don't know of any secret plans. I don't know.
Yeah, I was hoping
anything like that. I just know Terranode's real. I know there's a team of like, a dozen or more people working on it. And I was putting in 60 hours a week plus for 2 years on that. So, I mean, we were hitting it hard and it works.
There's gotta be there, like maybe if you don't know, but think about it. You doing 60 plus hours a week for 2 years, plus 10, 12 other engineers on Terranode doing full-time hours or more, that they're not just doing it for right? Like you're talking about what's his name? Calvin Air, basically, like
well, it's BSVA. Let's just be specific. This BSVA and the people that run BSVA, which I'm not sure of the entire structure because it's a Swiss nonprofit. It's got its own thing, but we'll just say the BSVA. That's their undertaking. Mm-hmm.
Right. So okay, got it. So it's not actually.
And they really
go ahead. Sorry.
No, you go ahead.
Well, I was just gonna say that has to is that the right word? Foreshadow basically demand. Like no one's gonna build a freaking 20, 30 what's a good analogy here? Nobody's gonna build a stadium if they don't expect to have
oh, you'd be surprised. We have something in North Texas I was born in the Dallas area and still spend lots of time there, lots of family there. And when they want to build a new freeway, they'll just build the thing. And they don't I'm sure they do traffic forecasting and whatnot, but they have to build it first and then the traffic comes later. So sometimes you need to build infrastructure in order to build the things that come next, right? Every app so far that's been built on BSV, it has suffered from lack of scalability. The architecture on most everything that's been made prior to the last year, maybe two, has failed on a lot of these projects. A lot of wallets, it's not everything, but we didn't even have the right SPV plumbing until maybe a year, maybe 2 years ago, right? And you need that in order to scale a certain way at the user level, the user and the app level, right? The core is even more critical because that sets you up for everything that comes after, right? Everything outside of that on the mandala, right? The core network. You have to get that right. And honestly, if the first Terranode effort would have been successful, there was a hype cycle that we were all riding in crypto then that could have looked different, if you would have had some real engineering happening back then. I wasn't around then. I don't know what actually took place. I know there's lots of drama, etc. But if it would have worked back then, I think we might be in a different place. We might actually have some of those scalable apps, but we lost a lot of momentum over time. And the new Terranode team is top notch. I really liked working for Siggy. Really have a lot of respect for those guys. I had a lot of fun actually because I got to bring my infrastructure work side to the table, and tried to be a leader on the team as much as I could.
How much of you know, I don't know if this is going to sound like a weird question, but like, how much of your experience with like what you did before getting into Bitcoin and Terranode is different, and like, and then if even Bitcoin is something different than Terranode, I don't know if that even makes sense, but like, how much of Bitcoin and Terranode is different from like the work you did with
Actually, it's not too much different, because at the heart of it, the new Terranode is just a microservices architecture. I actually didn't have that much experience with Kubernetes before I joined the team, so I had to really ramp up on that, and I'm still not a Kubernetes expert by any stretch of the imagination. But I had to learn that in order to learn how the orchestration works, because all these services have to talk to each other, right? And so there was definitely a learning curve there. But the infrastructure work from, say, optimizing and tuning Linux, speccing out the right hardware, network issues, right? Network bandwidth, routing. When routing would break, that was always my thing to fix, that kind of thing. A lot of that stuff I had already been doing for decades prior. And I actually have experience in very big data centers with very large deployments, hundreds of thousands of servers. I've done a lot of cool stuff. I always just wanted to work with really awesome network tools. I kind of became an architect over time, because I just knew I know how to stand up scalable operational environments. And it's not just about building it, but you've got to maintain it also. You've got to make it to where it actually meets the 5 nines if you're building for that, right? And there's a lot that goes into that. So
I guess another thing is, like, as far as like where does demand come from, is I'd imagine, like, does any other blockchain project have this type of engineering in their already? And so when demand comes into the entire, let's say, space, and then things start to shake under pressure and stuff, like, I'd imagine that all eventually gets redirected towards like BSV eventually. Maybe if they know about us, but maybe if they don't.
The thing is that BSV's core strengths are payments, right? And if you can architect a new way of doing payments that make people money, that's what we need to go after. And I'm kind of focused beyond the multicast network itself, because that's just the thing to get us to the thing. I don't know if you've ever seen *Halt and Catch Fire*, but it was a cool TV series about the origins of personal computing. Y'all should check it out. It's really good. But anyway, inside there, the guy says, this is the thing that gets us to the thing, right? And that's what I feel like the network actually is, because once we have something like that stood up, we can start to augment apps in certain ways that they are distributed widely. And we start to have these new primitives that we've never had before. Being able to create a command and control network that works across the planet, no matter where you are, very cheaply, it's huge. And the thing is, militaries need this, governments need this. There are so many use cases that what we need to focus on is getting the plumbing right, getting the education there on top of it, and then sparking imagination in engineers' minds. And I love all the app-based development that we've got going on. And I know some people, I know that was a topic on the episode with Connor, was that the enterprise versus startup app, small-time apps and whatnot. I think we need both, because the enterprise solutions, they take longer, but a lot of times they're more baked in, right? And payments are a business decision automatically, really. I mean, I guess you could accept payments person to person, whatever, but that only scales so much, right? Because of various reasons, legal, et cetera. So it naturally trends towards business, which doesn't have to be enterprise, but it certainly heads that direction when you start doing any kind of volume. So a lot of the things that I'm focused on beyond the network are network-borne problems that can be solved with Bitcoin. And the network is the largest source of what I identify as potential payment entropy on the planet. So,
Well, yeah, I'm speaking with some other associates or whatever, and we're looking at network, looking at hyperscalers, data centers, and saying, where does this fit? And I'm kind of saying like the North Star, that if we want to think about a product that slots in there, is turning the network into commodity type infrastructure that's paid for pro rata. So you just pay for what you consume, and you create spot markets for the utilization of computer resources. So the more of an infrastructure layer you are, the more you're delivering that computational resource or storage or bandwidth or whatever at saturation of the plane. Because if you've got spare capabilities in your bandwidth, why don't you sell that as a surplus? If you've got spare storage, why don't you sell that? If you've got spare cycles on your graphics card, why don't you sell that? And in periods of peak demand, you sell it for a high price, and when the demand drops, you elastically change your pricing schedule to respond to the market. And so when you buy a computer, like I've got an M1 laptop here, I've never used it really at its maximum capacity, but so I've never been able to really amortize the costs of the outlay, other than some efficiency gains in work and the ergonomic comfort of working. But if I could buy $1,000 Linux box and sell every part of it into an edge sort of, whether it's edge storage like as a elastic mesh CDN, or whether it's caching for that, whether it's selling cycles in a distributed supercomputer that's crunching data sets for scientific things, whether it's routing bandwidth to create the whole street having a Wi-Fi network that you can walk in and just tap into if your cellular network drops down, and you pay off from your neighbor. Like, all these things are available with Bitcoin, offering payments down into such a small level. And that's kind of the reality that's on the other side of saturation of the adoption of the technology, in my view. And it guides in the ideation of product and stuff like that. What can be created is anything that allows you to sell surplus energy, surplus resource you have into a market where it can be priced down to, even Craig's recent article saying sub Satoshi payment channels.
Mm-hmm.
So if you just need to settle it at 100 millionth of a $12 coin.
Yeah, and service providers always devolve into identity issues too, because if you offer up a service, you might have legitimate customers, but then you might have somebody that's trying to do something illicit. And it always, all of these solutions have to have a real strong accountability foundation, which is actually what makes BSV so attractive. But it also, it puts a lot of onus on the business owner to take care of that kind of thing. So there's actually a lot of work to be done with identity and all kinds of other solutions,
Yeah. And that's the issue, like, in the last, say, 2 years with the proper SPV plumbing, and we've kind of got proper SPV plumbing, but it totally changes the architecture of an application and the user experience. And it's still very, like, it's improved a lot, but it's very clunky in its own right into what people are familiar with, and it involves someone willing to embrace that friction to enter into a new paradigm, and they don't often realize that what a peer-to-peer paradigm offers them in terms of data ownership and privacy and such. So you've got to sell the value proposition, but still reduce the friction, make things as familiar as they're used to with a legacy experience. And a part of that is identity, to unify that and to allow you to exercise it and reap the benefits of data ownership and such.
And it's such a big fight because it's now at highest, the highest levels of politic and government, and a lot of these issues are being hashed out right now with competing technology stacks and competing knowledge bases. It's a very interesting time, and I just hope that the scalable solution wins. We're definitely entering into a new age, that's for sure.
To me, the fundamental contrast there really seems like every other solution that's been proposed for, say, digital identity and that integration of say a CBDC with your identity and with access to an IoT economy or sort of cashless economy. They all seem to be an account-based architecture. Like I haven't seen anything that's talking about it being UTXO. I just don't think they're fundamentally like divergent paradigms.
The people assume that UTXO wasn't scalable. That's the whole point. That's the whole error, and it's caused billions of dollars in development work that I think will ultimately just be scrapped. But you never know how people are going to react. Reality. If you would have told me back in 2013, 2012, 2011, whatever, we'd be sitting here talking about these kind of issues, knowing what has gone on with BTC, BCH, a million other competing things, I would have called you crazy. But here we are, and I never cease to be amazed at how things are turning out. This is the long, hard road for sure. But it's also very similar to what so I got into the internet very early too, because my first internet connection was around 92, 93, something like that. And then I started working professionally at the end of 94. So, I saw the rise and fall and rise of the .com era. The startup that I worked at was one of the largest. They were the largest raise of the 90s of the .com era. They raised the most amount of money of anybody back then, and it was wild because I was like the first technical hire at this thing, and it started like 95, so we rode it all the way to, well, I jumped off at 99, but it was, anyway, that's a story for another day.
Is it still alive, or did it die?
Say that again?
Is it still alive, or was it a casualty?
It was the worst invention of the 2000s. It was really invented in the 90s, but it was the worst invention of the 2000s. It was something called a QCat, which was a little barcode scanner that would take you to a website. You could scan any barcode in the supermarket and it would take you to a website. And that was part of the technology. That was the thing that everybody panned. They hated that part. But what we had done was created early scan-to-link technology. And the people I was working for patented all of that. And so it was my first introduction to intellectual property. first introduction to a wild startup, because it was also a TV show that ultimately ended up being syndicated in over 200 markets, 300 markets across the world. It was a TV show on computers and the internet. It was the world's first triple cast, so it was simulcast on radio, TV, and the internet all at once. We were one of Mark Cuban's early customers there at AudioNet in Dallas. Anyway, I got stories, dude. I got so many stories. It's funny. Anyway, seen some wild things, okay? And I also know that it took a long time for the internet to come back, right? To where we actually started to have useful apps. You know, that didn't start to happen until like 2008-ish, you know? It was like Web 2, right? The whole resurgence. Well, that took a long time, you know? If you consider like the beginning of the 90s as really the start of internet technology and people talking about it, and then the commercialization around 93, 94, and then the dot-com boom, bust, recover, you know, 2008, that was the time. That's almost 20 years. So here we are. That actually is 18 years if you count it like that. Maybe call it 15, whatever. We're in the same timeline.
And that was you know, massive amounts of money pissed up the wall. And
absolutely
in blockchain, you know, like I can't think of a successful, you know, product that's been built on a blockchain.
There's some well, it depends on your definition of success, but there are some professional blockchain enabled apps that I know are doing stuff like signatures, legal signatures, things like that, that are just running silently in the background, and you wouldn't know because
some that
I mean, if you can't identify the transaction, then you don't know what it is.
Sure.
Right? No voluntary
40 TPS. So, you know, success is something that's achieved at scale. You know, like there's businesses that are viable that are running on the chain, and that's success in its own right if your goals are just to run a viable business. But in terms of a flagship product or something that you can hold up and say this made use of the technology and it's like smashing it, I'm not aware of any. Like,
I mean, even the thing that I'm building, the multicast network actually works. I've proved it up to, so I've got a 25 gigabit interface in this lab server that I'm using, and I can get 16 million transactions per second on that server, one server. So I think at 400 gigabits, I can probably hit 150 million transactions per second on one server. So I would consider that successful, you know, because that means that I can scale the whole darn thing to 1 billion per second, no problem. All I need to do is stand up servers, order bandwidth, connect them. I already know the multicast stuff works. I've got an automated platform that will automatically converge everything across to a fabric. It even computes a Lambda 2 KPI from what they call Laplacian, which is another thing that Craig wrote about. Digital cache is a network problem first, or something like that. Well, I actually integrated that, and it works. You can you tell it. You say, well, if this network segment's weakly connected, it will flag it with an actual algebraic formula, and it gives you a number, and you know how to react to that number. You stand up another link and you increase the level of connection, suddenly you've got more resilience, right? It's a way to map networks.
Patchiness, spottiness kind of thing.
It's spectral network analysis is what it is. And I think it was mostly developed for like brain networks and such, but you could actually apply it to a multicast fabric too. So,
well, would you consider that a product on? I'm trying, because like when Todd said he doesn't know of any product, and then you described like the signature product, like, so you know that's more like an app that users interface with, right? Whereas what you're describing are users interfacing with?
Okay, so let's get to that part because that's
Yeah.
some juicy details here. Okay, so the core function of the multicast network is to distribute extended format transactions to Terranode miners. Now, extended format transactions aren't used in the overlay ecosystem, so they're not used between users. But this network can take in a beef format transaction and send it to a completely separate set of subscribers on the multicast network. So now you've got these ingress endpoints all over the world. You're sending to your nearest one automatically, and it just pops the transaction everywhere all at once. It's free for you to do, right? Well, you can do that both for minor transactions, so those are settlement transactions, say, or you can send a beef off and go to the overlay infrastructure. And actually, I just started up a discussion on the Babbage Slack about this. Anybody who wants to participate in that, feel free to. We need a way to connect the overlays to the beef transaction format so that overlays can receive a subset. So they're an active participant on the multicast fabric, right? So a consumer doesn't have to receive everything. You can subscribe, right? This is why it's layered. So the top level group is for blocks, Coinbase transactions, which actually have to accompany blocks, and anchor transactions, which are, think about a set of change transactions, right? Millions of them in a row, and they've all got a parent. Well, you send the parent transaction to the wide block channel so that all participants receive it, so that they've all got an anchor that they can use to verify up all of those chain transactions, right? Think about an app, right? You don't want to be waiting on something that's missing, right? So make sure those are all visible. Subtrees also have their own group channel for distribution, and the transaction shards themselves. And so you can do the exact same thing for beef also. So you have overlays on the network.
Could you explain what a beef transaction is? I know I've heard Todd mention it before.
Basically, it includes all of the ancestral information that you need to do an SPV offline validation. It basically just adds enough transaction detail that you can do extended validation on that transaction without having to fetch it from somewhere else.
Every output that you're consuming, it carries its Merkle path, or the interior node values of the Merkle tree for it to get to its Merkle root of the block that contained that output. So then when you're checking the outputs, you can do a quick check like, oh, this one comes from blocks 832,000, this one comes from 745,000. And if you've got 50 inputs that are being consumed, you'll have the beef payload will be 50 different different sort of like JSON strings of all the interior values. So you can recompute that Merkle root and check it against your local headers. And as long as it wasn't spent in the last block, you've got confidence that that was, not a double spent transaction. There are ways, like if you had 10 transactions that all came from the same block, you can kind of, there's different versions of beef where it can compress them all in and sort of deduplicate those interior node values if it was from the left side of the tree or the right side of the tree as you're recomputing that. So that's like a low bandwidth SPV thing that I think Craig published an article about as well. There's one of the BRCs is a V2 or V3 or something like that of beef to make it optimal around.
And remember, everything outside the miners, the overlays, the apps, the users need to be using SPV. So the reason beef includes all of that stuff is to make SPV work.
And when you do that, you can it's basically to recreate the pre-image that needs to be signed of the previous transaction. When you're signing the hash of the previous transaction, you need certain values that the miners used to have to look up to recreate. So in the extended format, you provide these additional values that are required to reconstruct the pre-image, and that's an extended format transaction. So the miners receive it, and if you've given them that extra stuff, it saves them having to do a lookup, and so they will kind of greatly appreciate an extended format transaction being handed to them, because it stops them having to go into their UTXO set, find the preview or whatever it is.
What does it
and
stand for, the acronym? It's an acronym, right? So
extended format, or BEEF, background evaluated extended format.
okay.
Yeah.
Okay.
An extended format is just a format of transactions that Terranode uses. It's got the locking script of the inputs and the output value. Terranode needs those two things, and if you can avoid a lookup, so if you can avoid having to go look up that's how you get high throughput, is avoiding these little things. It's these little optimizations at the various layers. So that's
it didn't even have value in, I think in the first like SIG hash algorithm, there wasn't even value in there.
Yeah, BRC 12 was never, it's just the transaction. It's just the script. It's just the it doesn't include all the information from the inputs. So you have to do a secondary lookup. It's just because it was the old way to do it in Bitcoin D.
I've got another super basic question. So you said BRC 12. I've heard, BRC 21. I've heard of 47, and I've heard of
You would have 42.
What are all of these like BRC, things? And
the way the way the internet works is they had something called a request for comment, or RFCs.
BRC. Okay, got it. Yeah.
RFCs, and this is a Bitcoin request for comment. So it's just a way for engineers to put out a memo stating, look, this is how you can build a certain thing, and I'm soliciting comments on how to make it better, or whatever.
Like a thread, basically like a thread, like a topic, a themed topic.
But it's from a technical level, right? So it's engineering related stuff. So if you wanted to define a protocol, right? For instance, BRC 12 is a definition of how to construct a transaction, send it over the wire to a Bitcoin node, an old school Bitcoin node, right?
Yeah.
That's all it is. And they can be different, they can describe different things. So
got it. So there's not goes deeper into that. Like there's not a 12A, B, C. It's just 12, 13, 14, 15, and it just keeps climbing and climbing kind of thing.
Yeah, and they're meant to supersede each other. So if you do some extensive work on whatever, a BRC number, and it's got a substantial amount of change, we'll just publish a new one, and refer to the new one rather than the old one. It's just a way to define engineering standards so that everyone is on the same page.
Sure.
When it was the Bitcoin Association back then, but they had the technical standards committee, and the idea was to formalize these things as technical standards, but it became sort of maybe a little bit premature and a bureaucratic process, and it wasn't that optimal in the way that it converged on a reality, because it said, for the first standardized Merkle proof, it kind of, a couple of people who were on the committee thought about it. They invited some industry involvement if anyone wanted to suggest it, but it had minimal involvement. And then they said, okay, here's the standard, we're going to roll this out. And a bunch of people were like, that doesn't serve me. I'm now bitter about that. And that happened a couple of times, and it basically just killed the process and said, this isn't working. And then the Ty really proposed the BRC method and seeded it with maybe 70 or 80 BRCs that he put in there, and that allowed people to debate the merits of particular ones, extend them, and suggest, let's do it this way instead. So certain ones became,
is it like a proposal kind of system, or it's like
it is a proposal? Yeah, that's all it is. It's just a proposal, and then most of the time someone's writing some code that uses that proposal, and puts that out also. That's what I'm doing. Is all I've done is taken a bunch of I've defined the different multicast stream formats, or the wire format that you need to put on the network for the proxy to use it, to send it along to the listener and to the consumer. So it's just defining that and kind of standardizing on it.
Got it.
Yeah.
But it's really led to a whole lot of the growth in that, the MetaNet based architecture is having those specs, and especially as everyone's now, or most people are building with a pair programmer with an LLM or something, being able to just shove, give them context around these ways of doing things, because formerly everyone would do something bespoke. Oh yeah, I've got this derivation scheme, or I've got this, way of broadcasting a transaction. And if you just, everyone's shoving, we're doing identity certificates, here's BRC52. You all know you're kind of working around something BRC 100, like it's so good now, because I'll sometimes use the MetaNet wallet. I can sometimes use the BSB desktop wallet. I've got my own BRC 100 wallet. Bridget can run it against her code. John can run it against his wallet, and it knows that create action does that. It knows that internalize action, like internalize a transaction, does that. So it's allowing people to build things that are going to be interoperable and avoid a money button type situation, or avoid a custom derivation scheme.
Mm-hmm.
Like there's some talk of Twetch coming back up now. It's like, man, I don't even know how I'd log into my money button account to get that key to
see, the thing is that you need to do it SPV now.
Yeah.
So, yeah.
Is it just that they're gonna revive the old, ways of things?
I don't know. I don't think the thing really worked super well before. I mean, it worked, but the idea of the payments, it was too much friction. See, they need to reduce friction. They need to reduce cost to where you don't even have to think about it. You have to think about beats.
They're anchoring it to an account-based model in there. Like there is, you do need to have an alias to be addressable, but it should be sort of managed in an overlay, and it should be against your peers. And in a sense, like I can be in someone's contact book as Todd, and I'm in their PKI or whatever. They know that Todd is me, and someone else can have a different @Todd, and you don't have the conflicts of an alias, because it's just scoped to your own PKI, your private keying infrastructure, and your contacts and the peers that are relevant to you. So you've got a simple alias rather than a key that's mapped to their, a type 42 derivation scheme and a key rotation, schedule. But, you can ergonomically just address them as an alias, but it's going to be a different key every time. So I don't think Twetch was originally architected in anything like that. It was using just an op return payload rather than anything that's a spendable token. And as far as it was pretty, like, it was polished, but it was still friction, and it didn't make the most leverage the technology in the best way, in my opinion.
And if the data is not federated, meaning I can't move it, or portable, I guess is the more accurate term. If I can't move it to another platform, that kind of sucks, right? That's a huge pain point now, because, I've got all this content on X, but what if there's a new, what if I want to move it over to Twitch?
Well, that's the whole promise, I guess, with the MetaNet, isn't it?
It should be.
Yeah.
It should be, because we own our outputs, right? That's
what
SPV is all about, managing and owning your own output.
It's funny because I saw that too, that they just in this last week, they're popping up. And I figured they were coming back because of the new infrastructure and stuff. But it would have been awesome if they really were coming back to run it in a really Bitcoin native way, as opposed to just coming back for the sake of coming back.
It wasn't Bitcoin native way. It wasn't a peer-to-peer native way. It was.
Okay.
It was like BSV 1.0 kind of way. We had the scalable blockchain, right? So throw everything on it,
Right.
but use it like the old Bitcoin, right? Well,
They
we
can't.
can't do that. We have SPV now. We've got all the plumbing for that, right? We've
So
got
it's-
So maybe
got the
they
stuff.
maybe they just need to consult with you guys and
They just need to put it in BSV browser and start building it the right way, and then build some killer features that people actually want to use.
building rather than silo and an account, you build it as a client that allows them to traverse an individual's own data, and in an overlay that is that protocol that's the Twetch Twetch protocol. So it's great. You've got a slick skin that allows you to navigate all your content that you've submitted to an overlay that they manage, but you can at any point sort of take your 0.5% of the contributions to that overlay and send them somewhere else. They still have like a carbon copy of your content on their overlay, but now you've taken your data and said, like, I want to move it to, I want to also publish it in this overlay, and I want to use this Twetch browser, which a Twetch sort of client, like how IRC used to work. You'd have Adium, or you'd have a different sort of client that gave you different features to publishing messages to your peers. That's how, like, that's the sort of purest architecture that I'm more like interested in, and really hoping to see someone produce.
But then there's privacy things that they could do. There's all kinds of things that they could roll up into that thing. Time will tell.
From Babbage crew, or like hopefully they've embraced that, and it is a 2.0 or something like that. If it's just resurrection, I'm sure people will jump on. There's some real loyalists in there that will.
I've been hearing about it.
I know. Don't think we're bagging on Twetch. We're not. It's awesome.
I used
to like all those funny memes. That the dude would. What was his name? The guy that was
Moist.
Yeah, but what was the guy's real name? He was at CoinGeek a couple of times. The conference, right? Petty. Josh Petty. Josh Petty. Yeah, he was funny.
Yeah.
I don't know. Anyway, if we could get more of that energy back, that'd be awesome. But with some good apps, really good stuff.
But that's tricky with those ones. Like if they're going out with their own client, like Tree Chat's awesome, but I just forget to go back on there. Like I don't really want to get sucked into another like app. I'd rather have this efficiency of everything's coming through one app, and I discover check everything that's relevant to me that's on the metanet.
This is why portable data is so important, because if you're building a corpus of work, you don't want to have to leave it behind and go redo everything every time, or every 10 years or whatever. It should be portable. We should be thinking ahead.
Yeah, and I think everyone should be, instead of paying your $10 a month subscription to some crappy SaaS, everyone should be running a $5 VPS, and that's their story.
A little bit more, Todd, about just explain a little bit more, because this is kind of what John was talking about, right?
Well, so like I've got at the moment I pay $2 a month or something to Google Cloud to get my 100 gigabytes. But then I also, let's say Dropbox or a couple of other things like that. Maybe there's some, storage that you want there. But I'm still using their infrastructure. Like if I have a VPS, a virtual private server, I can get one for $5 a month that's got 20 gig on it, and a crappy little computer on it, or segment of a computer. But I could be using that as my cold storage. I could get an increased storage plan for $10 a month or something. I still have a crappy computer on there, but I've got now 80 gig or something, and all my content that I create on the metanet is kind of mirrored on my VPS. And
it should be It should be mirrored on multiple storage providers that compete for your business. And actually, I would like to see finding a floor, a pricing floor for everything. You know, so much of this world is focused on pricing higher and higher, more spend, right?
Yeah.
I'd like to see the opposite. I'd like to see things getting so ubiquitously cheap that storage providers are falling all over themselves to get you to store their data, and all you got to do is spend a few satoshis to do it. And you pick 3 of them and they're done. And the thing is that this, you know, not to bring it back to the multicast network, but I'd rather send one packet and hit all of them at once without having to even think about it. And I feel like a lot of these application distribution issues and resiliency issues and just the architecture of the way that they work, I think that they could benefit from something like this because of coordination, right? One packet everywhere.
Yeah, deduplication.
Exactly. And actually, that's kind of an inbuilt feature of this multicast network, that it can deduplicate TX-IDs. So if you had, so it can actually enforce the first scene rule at the network level. Whether or not that's a good thing, we can debate that, because there's a latency right across the planet. And if you injected the same transaction at both ends, you could, you know, if one was a few milliseconds faster than the other, well, then certain Terranodes that are closer to that side might get it faster than this one. And then you might still have the same problems that Terranode has to work around with competing transactions, and whoever wins the block's going to win. And, you know, it's got all that, but you could do it.
But if you put drop on there is a docx, who's going to double spend your changes to saved changes to a document?
And this is why small outputs matter mostly, because they become economically uninteresting.
Yeah,
they are not worth trying to fight for them, right? Yeah.
You know,
it's
Salesforce or something like that, and they want to do some kind of intricate embezzlement, and if you send that purchase order quicker than that one, you can front run it and get access to a contract before. Like that's where the double spends can have a significant economic upside in a giant world of like ERP or EDI or something. And it's like, if I can double spend this thing and get an approval and blah, 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 but that's up to the business to manage that side of things with data access management or data event management, which can all be done on there, and you just have a 10-minute settlement window or something before a particular. And it's that when Craig talks about it being epsilon bounded SPV, this cap theorem mitigation through bounded epsilon thresholds, that you're saying, and of a small value casual payment, you can have almost an absolute guarantee, and from higher value things or higher value sort of consistency requirements or availability requirements under cap theorem, you just go from like a less optimistic eventual consistency and reconcile it at a 10-minute interval or a 60-minute interval or something.
Yeah.
Don't allow down mutations on a unconfirmed spend yet.
There's a simple way to treat it also, and that was a topic of conversation developing Terranode, is if you've got a double spend on the network, there's only 2 things that it is. It's either fraud or it's a bug. So just drop both of them.
Yeah.
Put them in the sandbox for a while and don't refuse to deal with them as a policy. I mean, let them submit it later, but just refuse to deal with it.
It's not an immediate blacklist, that IP. It's just like, time out, send it to the next block. You let you diagnose why it's not working, either improve your fraud or sort your bug out, because it's
So I'm pretty sure that is a setting in Terranode. You can enforce that. So.
I remember that being declared. Yeah.
I have a question for you, Jeff. Is there anything about Bitcoin's original design that you think could be better or tweaked that would help the design implementation of Terranode today? Like you guys are just talking about like these 10-minute block times and stuff like that. You know, there's blockchains to millisecond block times and second block times and stuff. So I was curious, you know, if you had any questions or doubts around the original design of Bitcoin.
No, because Craig has explained it incredibly well over the years. And I know that a lot of the source material that he wrote is not available anymore. A lot of the talks aren't available, and people, maybe newcomers in the space over the last couple of years, may not be aware of all of the technical arguments, but I was pretty well convinced over 10-minute blocks. Hard
Could you give a little like you know, summary of, and we take us back to where
I'm also not the one to. You know what? That's something that like Brendan Lee or Connor, or, one of those guys could really articulate it well. But to be honest, man, it just works. When you look at the scaling path that we're on, once you fix the network, mind you, which is what I'm working on. I believe so strongly in this that it really needs to be done in order to.
When you say that, once you fix the network, because like there was a question I wanted to ask early on, but I guess right now it might be relevant, which is like, what is the difference between the Terranode now versus the BSV node from before? Is that what you mean by fixing the network?
Well, that's part of it, because we had to get rid of the legacy RPC, not the RPC interface, but the legacy peer-to-peer. I think it's actually called legacy in Teranode now. That's the way to transmit blocks that contain all the transactions in them, and then a node verifies everything after the fact, right? Well, in Terranode, we flip that upside down. We validate transactions continuously. We wrap them up into subtrees every second, and we announce those subtrees to the network. Other miners pull them. That way they have groups of pre-validated work to quickly attach to announced block templates. So in a block template gets announced to the network. It's got all of the pieces of the 80-byte header. So it's got the Merkle root hash. It's got all of that stuff. And the Merkle root hash actually rolls up with all of the subtree identifiers, which are each hashes. They're each sub Merkle root hashes, basically. And all of them add up into the same cryptographic tree, basically. But what that allows a node to do is to quickly verify and move on to the next proof of work, right? Now,
sorry, as opposed to what? I didn't.
As opposed to doing all the work after they receive the block.
After they received it, so they're doing the as it goes versus.
It's an attack vector. It's an attack vector.
Yeah.
The old proof of concept, I feel like, was done intentionally because. Okay, think about this. All right. The way that the hash wars work right now, somebody with an overwhelming amount of hash just keeps producing blocks over and over and over. And before someone with the minority hash can even validate them, right? Or can even do a new work, right? It's an attack vector. And the BTC guys talk about this all the time. Well, with Terranode, you're doing the work continuously. You have to do the work. You have to verify the subtrees. You have to download them. You have to check them. Right. You have to transmit them to others. Other people can see your work. Other Terranodes, other miners can see your work as it's happening because you're transmitting this information continuously every second in the subtree structure, right? So you can make, and this is where Ty's arguments are brilliant, because miners are going to have to start doing, they're going to have to start looking at that actual proof of work to see what miners are expending resources and which ones they should be paying attention to and which ones they shouldn't. And if a miner that's got a ton of hash power, but very little work that they're doing, right? They're not actually linking all of these transactions. They're not validating them, doing the hashes, building them into the trees, and sharing them with others.
A purer form of proof of work in a way, right?
Yes, and you can start to do an objective evaluation of the people that you are building on their work, right? So if this adversarial miner is advertising these block templates, which are sparse, which are lean, which don't have all of the subtrees, they're not doing all the work, what are they actually accomplishing? Well, not a whole lot if the other Terranodes are paying attention, right? So just by changing the peer-to-peer format, I think, I mean, it's not perfect. I think you could still game it, you know, if you had a bunch of hardware, whatever, but it's a different paradigm because you're shifting the proof of work to not just after the block. It's not just block oriented. It's transaction oriented. It's everything in between, right? You know, a lot of this stuff isn't built into Terranode yet, you know, evaluating other subtrees. Some of it is, you know, they check it for technical accuracy or whatever. But I just think there's a lot that can be done with those structures. And I think there's a lot that hasn't been talked about with subtrees. I think that there's a lot of magic there that has not been developed yet, especially for like users, for transaction specialization, so specialization of miners. Things like that. The network format that I have includes a subtree ID, so you can attach a subtree ID to a transaction. And then it has the ability to filter based on those subtree IDs at the edges. And I created kind of this rudimentary subtree group announcement protocol to where you announce group membership of new subtrees, and by that you can automate certain infrastructure, basically on the consumer side, so that you're only delivering a subset of the traffic. Now, this is the part that wasn't explained really well in the Multicast and Multicast blog, and it's the part that I've struggled with, because I think a lot of those solutions are still being kept tight-lipped right now. I think we have just the barest details of what subtrees are. They're expressed in the Go subtree library now and in Terranode, but I think that they can probably do a lot more. So
that was when I wrote up that Merkle Trees course on the BSB Academy, that I actually didn't formalize it as a subtree, but I was saying that in the future, I'd imagine that a node is there, and say transactions A through to F hit the network. You might receive them. You're a node operator. Anil, you're a node operator, Jeff, and one might have it as like A, C, B, D, E, F. The other might have it as A, E, C, B, E, F, depending upon the different way that you've received them. So your Merkle trees are going to all have a different route. So I'm there as an operator, and I've got Anil's, you've streamed your subtree at me. So I've said, okay, that contains transactions A to F. They're all valid, but yours has a different ordering. So you've got a different Merkle route, and Jeff, yours has a different ordering. But Anil, you then the blocks produced by you, Anil, and you've also got a transaction G. So when that comes into me with the block, it's like, you've got subtree 1 and you've got subtree 2, which also has transaction G in it. So I need to then just poll to get the missing ones that have occurred in the last interval that weren't on that first subtree. But I need to have sort of cached your Merkle tree, the Merkle tree that I'm building for you, and the same one as that I'm building for Jeff and all the other peers that are worth connecting to. So I've got sort of building maybe 6 in parallel from my highest confidence nodes that I subscribe to their trees, and they've got a different ordering, but 99% of the transactions are in there, and then at the end I just poll for the missing ones that have came in before that last subtree announcement. If the block occurs, in discrepancy between that, is that occurring? Are nodes building the other subtree?
Yeah, Terranode orders subtrees from its own vantage point, and every Terranode has its own subtrees, and they have to share all of those subtrees with all the other Terranodes. So actually, the multicast network helps here too, because a miner should only have to send that subtree up to the network once, delivered to everybody, rather than deliver to all of them. All of them have to. I mean, subtree data is not very big at 1 million per second. It's like 32 megabytes per second, but it grows, 320 megabytes per second when you get to 1 billion, right? Or is that right?
And
Yeah. Yeah. Well, whatever.
Yes,
You're right. You're right. It's a lot more than that. Yeah. So it becomes a data problem on its own. And actually, it becomes even more of that. And part of my work on Terranode was figuring out low latency storage, shared storage systems for the cluster to use, because those subtrees get stored as files. When they come in, it's just binary data. And you need to be able to share that with all the services, because all services need to have access to all subtrees continuously. So a lot of the work that I did was with Lustre file system and driving that low latency shared storage access to it. Also, in the later revisions of our work, I was working with tuning NFS to do the same thing. But I think as it scales up, it needs a really robust storage system. So that's its own distributed problem, right? Storage.
That's Aerospike. Aerospike was the UTXO for the lookups, and then there's just for the subtree storage. Is that isn't it event stream, or is it something that's
there's Kafka for the message bus. So that's how Terranode coordinates all of its operations between all the different services. Shared storage is for the quorum data, subtree storage, transactions which won't fit in Aerospike have to go there, because Aerospike actually has a limit on the record size. And so they had to work around that issue with it. Aerospike handles the UTXO store. Postgres handles the actual blockchain database. So just the blocks and all of that data. So it's actually a bunch of different systems that have to tie in together.
Do you know Derek Moore?
Yes, that sounds very familiar.
He had a system, Pravega, and back in the day, like when Shadows was doing Terranode, he said they're not going to be able to scale it with Kafka. They need Pravega. He needs to come and talk to me. So I don't know. I know what it is. No,
and they're actually not using Kafka now. They're using something called Red Panda, which is a C implementation of Kafka. So Kafka was built on Apache, Java, that whole ecosystem. And somebody came in and said, you know what, this doesn't work at all. Let's redo this in C. And they launched it as a commercial, open source community and commercial offering called Red Panda. So it's way more scalable. But you're right. It only scales into a point. So that, there's always going to be a need to look at the next layer, and there's so much to optimize too. Like we haven't even got into like optimizing script, and Dr. Wright has also published hardware methods of, it wasn't floating, it wasn't gate arrays, it was I think it was ASICs to speed up the validation process greatly. So you put all the opcodes in silicon basically. And so every transaction takes nanoseconds to validate now. And it's a card you can pop into servers. I mean, these aren't built yet, but the foundation is already there. He wrote about it. He posted Verilog files with it. Like anybody could go and build one. I mean, as soon as we have that, you start to optimize that part. You take Aerospike and you take that magic that they're doing with NVMe storage. See, what they're doing is they're exploiting key value store built into the storage networking industry association tooling that they've come up with. It's a direct interface to the NVMe device. So super fast key value store.
Because there's a CPU on the NVMEs, isn't there? So they can actually have like a little lookup against the mmap or something of the file there.
It's basically a hash index lookup on the hardware itself. And so Aerospike is taking full advantage of that and getting you as close to the hardware as you can. But there's nothing stopping anyone from building a purpose-built UTXO store that does kind of the same thing. When we were talking to Aerospike's people, they said that they had that 280 million transaction or query per second commercial customer that they had. It was running on 1,200 servers, and these were like not high spec servers. These were like commodity boxes, but 280 million per second. Like you can, you know, it scales.
Yeah.
It scales, right? And if you can do it even more streamlined than that, because Aerospike does a lot of things that Terranode doesn't even need, you know, so strip all of that stuff out, make it handle just UTXO records, just do the operations, just focus on efficiently implementing every operation that needs to happen on the back end. Every single piece of this is designed to be scaled. Every piece, the whole design. I've never run into anything where I think, yeah, that runs into a wall right there. You know, never been able. And I haven't seen it with this multicast solution either. You know, as I was a little apprehensive about when I first started it, like, okay, is this thing actually going to work? But I've got it in the lab and it actually works. I mean, the system that I've put together has reliability at every tier. So at the Ingress level, it uses BGP Anycast, multiple Ingress proxy points with blast zones for BGP, basically, so that it fails back gracefully at the regional, the local, the regional, the geo level. On the consumer delivery end, the way that I've designed it is 2 tunnels, either WireGuard or GRE tunnels, either IPv4 or IPv6. I do an A and a B tunnel. The feed only ever comes on one at a time, but I use portable IP addresses between them. And I use BGP at every layer so that if one component blows up, it automatically routes the feed to the other one, and the retransmission system automatically replaces any missed packets, so there's no gaps. So it's 100% reliable delivery from end to end, even if the entire data center melts down, goes on fire. So it's designed to be completely resilient at every corner. It also, well, I guess I'll wait for Todd to get back to get into more juicy details, but it needs to be reliable. That's, you know, it's
crazy. You were talking about like what Craig mentioned, or not mentioned, but like wrote about, that allows us to optimize just the physical devices even further than ASICs. And there's just thinking about all these pockets and areas of opportunity to optimize it. We're already at 1 million, and like, you know, the path to getting to 1 billion it seems like
it's not it's not a big technical problem. I mean, from Terranode, there's a lot of things to solve. I'm not going to sugarcoat over, you know, the back end part of it, because there's a lot to it. The block assembly service needs to be made more resilient, for instance, or more scalable, I guess. But a lot of the pieces are there to where if we just start applying these optimizations at every level, bit by bit, and then we get the throughput up high to actually exercise the system, to find all of these edge cases and to get there. 1 billion per second, totally doable. I mean, I could build that network today and I could demonstrate it to you. It does work. It's not fanciful. From the transaction distribution point, I 100% guarantee you it works today.
1 billion.
If I had enough hardware, I could do it for you right now. And in fact, if anyone wants to help me get there, help me.
What's the ask, the plug, man? Go for it.
You know what? I just want to see that. I just want to see us actually scaling this thing. You know, it's scale or die. And I'm all about the technology. I'm all about the engineering path. I just want to see us succeed, because this is the most important mission on the planet. I feel like we need full accountability at every layer of the human existence, I should say. That's a little dramatic, but
Yeah.
I'd settle for just scalable electronic cache.
So we had Bridget on the other week, and she was talking about where Bitcoin sits in the OSI stack, and she said, at the moment it only sits in the application layer, but
Not true. Not true. It can actually insert itself between every single layer.
Well, that's if you're talking about with V4 and the way that it currently is, it really only is at the application layer with IPv4. But once you embrace 6, I was saying, I think it sits at all the layers, but with the transport, say it really only sits there with. It would need a different wire format or something like that to embed, sort of economic routing to the header of UDP or TCP or something like it.
Well,
having kind of extra routing table there for it.
Well, it doesn't even need that. I mean, think about, so layer 3 is the addressing and it's the IP layer, basically. Yeah. OSI layer really doesn't map to what we're doing today, first off, because it was written in a different time from a different engineering viewpoint, etc. But, layer 3.
What is OSI layer? Is that?
It's the Open Standards Institute layer. It was a way that they came up with, I think, in the 70s to start to do engineering. And it was sponsored by the ANSI people. So a completely different track from the IEEE family, the IETF. I'm not a historian on all of that stuff. I just know that they had a different path from different engineering.
Like part of this stack, right? This internet stack where it's like physical layer, then there's this network layer, then there's the port layer, then the application layer.
It's the physical layer, the link layer, which is Ethernet, basically, right? The network layer's IP on top of that, and then transport, which would be TCP, UDP, and then applications and stuff on top of that. But we could do payment. There's nothing stopping anyone from designing a protocol for Ethernet, an extension that can do payments across an IP link, and there's nothing stopping anyone from doing the same thing with internet also. And if you look at Bitcoin certified addresses, like some of the work that's being done, that's layer 3, right? Bitcoin could actually be used as its own transport protocol if you really want to get down to it. We could embed IP packets inside Bitcoin transactions. You could do all kinds of things.
But so that's what Bridget was saying, was that like Bitcoin right now only exists at the application layer, the very top layer, but not to say that it cannot be further developed into these deeper layers, though.
Yeah, it's meant to transcend all of the layers. It doesn't mean that all the work has been done, but I would argue that we're already doing layer 3 work.
Layer 3.
In addition to the application layer, because CGA Plus is IPv6, right? Part of the addressing standard.
Semantos, I'm tinkering with that, like sending direct Semantos cells. So they're the wire format, they're the storage format, they're the compute format. So it's giving some very interesting possibilities in the way that, like, for example, when the cell is in storage, they're 1 kilobyte cells. So you bring up a database page, 4 kilobytes, you just grab that off, the 1 kilobyte chunk, and you don't have to do write amplification where you would grab off, the 4 kilobytes, then take it up, just grab that 100 bytes there and, to make the edit and leave the rest of it in RAM while you're doing such things.
Yeah.
Like you bring it from storage, you send it out the network port. You don't even have to cross the motherboard. You don't have to serialize anything. So like, that's just experimentation and seeing what happens there. But there's once you embrace like BCA that's derived from the keys, and if you have some, there's a previous hash of the the state of the cell, so you have almost like a monotonicity there and a sequence number or a sequencing, so you could get retransmission of missed intermediate states. So that's like that's it's using UDP, or it's using it as a custom wire format, just on a little mesh on a LAN that I control. But that is touching that layer in the stack, and if there was two compatible routers on either end, they would be able to go, great, this is still intact at the other side, and decode it.
Yeah, I do some optimizations with slices and memcopy to keep the proxy path zero copy as much as possible. And also I shunt it to user space networking and the commercial solution. So the open source proxy is just a kernel based solution that pops out at maybe 500,000 transactions per second on a 6-core PC, right? Which is actually pretty good. Like, it would work for our needs, but the commercial one on the same hardware will do 16 million. Using a combination of user space networking, address family XDP, and a bundling frame format. So most BSV transactions are small. They're like 216 bytes on average for pay to public key hash transactions. And so you can stuff a bunch of them inside a 1500 or 1440 MTU packet. So you actually get more throughput that way. The multicast network's designed to accept single packets in, bundle as many as they can over the links, and then single packets out. Unicast at the edges, multicast in the middle.
Yeah, that makes sense. And even if you're talking about Ethernet there, but if you get access to a laser or something, then the frames can be bigger, and then like there is capacity for 4.3 gigabyte jumbograms.
There are, but actually that's a problem. So they did experiments with MTU sizes. We have jumbo packets, which is like 9216 bytes or whatever that can go on the wire. And they did experiments about 20 years ago with super jumbo packets, which were 64K. And you know what they found? They found that there were problems with CRC32, that it actually tops out because it doesn't have enough collision space and some other technical factors, like it's not robust enough. And we use CRC32 hardware error correction for everything. So they just decided, well, we've got to, you've got to overcome this, and it's a hardware problem. Chip manufacturers need new hashing algorithms inside the, new checksum algorithms, et cetera. So it actually becomes more problem than it was worth just sticking with jumbo packet sizes.
Is that saying essentially like the boundaries of the pixel of the frame or something like that? You get bleed there or something like?
It's got to compute a checksum of every single packet, right? And when the packets get too big, I butcher this explanation. There's problems with CRC32 with super jumbo packets. Let me just leave it at that, because I'm going to butcher. It's too late at night to try and explain that. But there's papers written about it from 2006 or whatever, when researchers did some of that. I'm sure there's been other work done, but that's kind of why they're sticking with 1500 MTU, because most network devices, that's kind of the base that everyone's always used. A lot of people hate it. It's caused all kinds of workarounds, fragmentation protocols, and I've got a fragmentation protocol for the multicast stuff, because if you have a 10 megabyte BSV transaction, you need to split it over multiple packets. So there's I can't remember which BRC number it is, but there's a fragmentation packet format. But the thing is, the user shouldn't have to do any of that. That's all on the network operator side, right? So I'm aiming for EF transactions in, beef transactions in. Distribute those separately. No funny business otherwise. No new tricks. There may be something that we have to do to connect transactions coming into the network to overlays. That's a discussion that I brought up on the Babbage Slack recently. So
using maybe like version number or something there?
Well, they use a transaction version number, and there's 4 billion combinations, but that just gives you 4 billion address points to send those packets to? Is that enough? Like, you know, and then who maintains the order? Like, and if you pick transaction version 8, but somebody else picks the same one, and you both send packets to the network, and they're both hitting these overlays that both want. Is that reasonable? I don't know. I mean, I'm not in the overlay standards group, or whoever that probably doesn't exist, but you know,
I don't think it does.
It's not my it just hasn't been my bag, you know. So there's things that we need to figure out there, but the main use case, delivering EF transactions to miners in a scalable fashion, in a way that they can, if any one node on the multicast network blows up, it automatically routes past it. It automatically repairs gaps. It's miners need reliability, and I feel like by creating the right network structure, we could benefit the whole ecosystem and all the miners at once. Like they don't have to worry about network issues. You know, that's and this is the only way that it scales past a certain threshold, you know.
And the only way accessible to a business who comes in, if you get an enterprise to come in, they don't want to be experiencing infrastructure issues on this. They just want it to be like, you told me this scales to 1 million TPS, and they want to just never face a hiccup on that side.
And I've built this network to where a miner or a service provider could bring their IP space in and actually advertise their own ingress IP addresses on the same network, to where they just ride the same endpoints and get distributed just like everything else, but it's using their domain name, their IP address, their everything. So it's designed for the commercial path forward. And like I said, it survives interdomain ASN peering, you know, so it could grow past just one network. Yeah, I mean,
Sounds pretty well thought out.
I'm trying, you know, I have experience in ISP design and management, and that's really helped here. And actually, I worked at a startup a few years back that had an aim to create apps that worked all across the world, and it would spin up resources based on need across the planet, and it would just operate seamlessly on the same IP network. And they had a goal of, we were supporting like 5 or 6 different clouds all at once. It was kind of cool, and it actually gave me the experience I needed to tackle the organizational side of this, some of the BGP issues, some of the Anycast issues, because that's what we were doing way back when. So you know, it was actually right up my alley. I'm really happy to take this thing on. I wish I had some help on it. So far, I've reached out to Dr. Wright a couple of times, but I got radio silence, and I'm guessing either that's because he can't talk to me, maybe because of, you know, I'm former BSV or something, BSVA. I'm not really sure. Maybe he just doesn't have time for it. So
got too close to his secrets.
Well, no, I mean, he put the information out there. Like, he told how to build it, right? So, and he's the one who says all the time, just go out there and build, do the work, you know, put in the hours. And here I am. Like, I heard that call, man. Like I said, Terranode was my dream job.
Exactly.
I heard it loud and clear, and that's what I'm doing. So I hope that maybe he could release a follow-up blog article that maybe answers some of those things about node specialization, how to use the subtree ID to filter on, like, are there different, he mentioned hash algorithms that could create that subtree ID, like they could do different things, right? Maybe what are those some of those things, right? Also, how does the NAR and DAR fit in with this? Because I could see a dedicated multicast group subscription channel that's widely disseminated for network access rules and recovery. Yeah, because that's really important too, right? So there's just certain things that there's pieces that weren't completely discussed. I've figured out the hard ones, like the retransmission stuff, the NAC-based retransmission, even rate limiting with that, even solving the whole multicast reflection problem. So if let's say we have a minor consumer that's receiving transactions, they're also sending transactions up to the network. Well, they don't want to see those transactions reflected to each other. So there's actually some really cool things that you can do with that composite hash key, the retransmission key, that you can dedupe that traffic back to their flow, back to their thing, so that they're not receiving a mirror image of everything that they're sending out, because by default that happens. So I've had to solve some pretty interesting engineering problems, and some of the BGP work where if an edge dies and their tunnel suddenly crashes, well, rerouting to the other one seamlessly, retransmission system fills in any gaps, new hardware gets spun up, second tunnel comes back in, same IP address, no reconfiguration needed on the consumer end. Some of that stuff is actually useful engineering that, someone needed to figure out to make this work. So, and it all scales up to data center handoff port connections. Someday miners are going to be in big data centers and they're going to want to talk really fast to the network. So this thing that I've built scales up to that. So 100 gigabit connections, terabit connections, whatever.
Well done. Anyone listening, if you feel you can help in any way, how can I get in touch with you, Jeff?
Yeah, just go to onebsv.net. It's got a link to all of the open source code, GitHub repositories that I've developed everything on under. My company name is Lightweb Inc. It's based out of Texas, USA. I'm just a one-man show, just wanting to keep up the scaling Terranode. If I wasn't on this, I'd still probably be working on Terranode and making it better and aiming for 5 million, 10 million transactions per second. But honestly, like I said, I think we need to solve the network first. So it's going to be sooner or later. This is going to have to get done. So you might as well just get all the hard stuff out of the way while I have time.
Oh, well done. Anything you want to cover that we haven't?
No, I'm just I'm just here like everybody else trying to make Bitcoin better. And I believe that it's truly one of the most inspiring missions on the planet. And I'm happy to do my part.
Yeah, cool. Well, I don't know how much I can help with the acronym soup that you've been tossing out for me. I understand a fair bit of it, but I don't have that much to offer. But happy to be some eyes and peer review stuff and just give some feedback and at least send an ACK.
Thank you.
Yeah.
Thank you. I welcome any kind of input. I'm kind of working on this in a vacuum. I'm the only one that I know of that is even in this realm of network engineering, systems engineering, distributed systems. So I welcome anybody. Let's talk about it. Have discussions. I'm easy to get along with, and I love outside. I love it when people tell me I'm doing something wrong, because then I can go and fix it. I try real hard not to have a big head about things, and just I'm pleasant to get along with. So feel free to reach out, anybody.
Cool. Well, hopefully that if you're listening and you've been excited and inspired by this, feel free to reach out or reach out to me, and I'll put you in touch, and we can facilitate a working group or some collaboration here, because I think what you're doing is very important. I think that there's probably very few people in the world that can approach solving some of these problems, whether it's the legacy, having the skill set in the legacy networking engineering, and then also having the expertise of the I guess the corpus that's been sort of published around the vision of what can be achieved with the blockchain. Like a lot of the people who've seen blockchain so far that may have the networking expertise think that it's a dead end, think that it won't scale, and we're showing that it will, but we're doing so in a little veil of secrecy, not our own secrecy, but a radio sort of blackout on our the communications of the capabilities and such. So I just want to get the message out of what is available, what can be done, where we're going with this, and if you have a problem that sub hundredths of a cent payments, you would welcome those in, or you'd welcome data integrity solutions in the operation of billions of transactions a second. We're probably the only technology that I'm aware of on the planet that can provide a solution there. Not without some hard bridges to be crossed and some serious engineering challenges, but there's no hard ceiling that I'm aware of has identified saying, nah, this isn't going to work to accept a planetary scale of transaction activity.
Mm-hmm.
So thanks so much for coming and joining us today. And anytime you've made some more developments and you want to come on, and it sounds like there's plenty more. We've only just scratched the surface of some of what's happening.
We have, like I said, this is the thing that gets us to the thing, and there's a lot more things that are tossing around in my head, because once you have a network, you can start to develop real services. So, yep.
Amazing. Yeah. Anil, anything from your end, Anil?
Yeah, I've got a few tiny questions, but I'll leave it to after we wrap up here. I'll ask offline. But I love this deep dive that we did here with Terranode. I just, I feel like we could do like a part 2 and go further. And I want to. Yeah.
Happy to. Actually, when I get the Terranode integration done, I just developed an engineering report, shared it with a few of the developers on what identifying the engineering gaps that Terranode has now to get us to this. And it's actually not very much at all. It's pretty simple overall. So I'd be happy to talk about it again, maybe once it's a little more solidified, and maybe once the network is actually launched. So
cool. Look forward to it. All right. So yeah, thanks everyone. Please, if you've enjoyed the conversation, like and subscribe, and stay tuned for more content like this as we go and flesh out the technical details and bring a level of conversation to the serious engineering that's occurring on the BSV network and the problems that we can solve for anyone really. So thanks a lot.
Yeah. Thanks for having me on. Appreciate it.
Cheers.